All right, we're on EQ 27. This means you have 2 left after this. 2 sets of notes after this, 2 EQs, because you're going up to EQ number 29, is where you guys are going to end the third 9 weeks, so we are getting close. So in the last lecture, sorry, trying to get comfortable. In the last lecture, if you remember correctly, we filled out this chart, right? So we talked about these 5 types of reactions: synthesis, decomp, single, double, and combustion. So what we're going to do in this PowerPoint, these actually go together pretty well. So the last one was easy. You just had to be able to recognize these types of reactions. In this one, you're actually going to have to predict the product based on the kind of reaction it is. All right, so like it says, describe how to predict the product of a reaction. And what I mean by that, simply, is, sorry, I don't want to write on my table, is that if I give you, something like sodium plus chlorine, your job is going to be to predict what it's going to make. Okay, so we're going to learn how to predict the product for all 5 types of reactions that we talked about. Sorry, the meme game has been a little low. We have surpassed the internet's ability to supply funny memes for chemistry because people don't make memes when it comes to this kind of chemistry stuff. So you guys go out there, make some memes, put them online so that I can use them next year. Okay. I don't have any. I couldn't find any. And I'm not witty enough to make them, so sorry. Okay, so first part of your box, you got a copy of this chart. You're welcome, because this would be a lot to write otherwise. So you shouldn't really need time to fill, you shouldn't have to pause this one at all. You guys have a copy of this chart. So let's go ahead and we'll fill in the blanks. And then we'll do the 3 examples for each one. And move on to the next one, and then we should be good to go after that. So, first one is synthesis. We're going to go directly in the same order that we did for the other chart. So, synthesis is the first one. All right. This one's pretty simple to predict. Okay, because synthesis, we're just taking 2 elements and putting them together, right? We know in synthesis, that's what all we do is take 2 smaller things and combine them into one. So this is kind of like ionic compounds, ionic bonding. This shouldn't challenge your brain very much. Okay, so first thing you want to do, figure out the 2 elements you're combining, and you do that just by looking at the 2 elements you're given to combine. Next one, you want to find the blank of each. What do we know about, oh look who's back. What do we know about ionic compounds? What do you have to do? What do you have to look up in ionic compounds in order to make them? Hopefully you are thinking charges. You have to find the charges of each, right? Find the charges of each, and then what do we do with those charges? Hopefully you are saying cross over your charges. And then the last thing you have to do is balance your equation. Okay, this one's very simple, not a lot of steps. So if we're going to do these examples, so what I'm going to do is kind of write the products down here. For this one, I'm going to have to rewrite it. Oh, goodness. Oh, that's pleasant. I'm going to have to rewrite the middle one because it's in words. We're going to have to write it in formula form. And then we'll just write the products for the other one down here. Okay? So, first one, calcium plus chlorine. So all we need to do is figure out what that's going to make. Alright, so let's go ahead and follow our steps. The 2 elements we're crossing, calcium, chlorine, right? Find the charges of each. So if we're going to find the charge of calcium, what's the charge of calcium? Hopefully you are saying +2. I'll zoom in so you can see these a little better. okay? And then the charge of chlorine. Now I understand it's Cl2, but notice that's only because of Brinkelhoff that it's Cl2. So look up just the normal charge of chlorine, which in this case is -1, right? We've got +2 for calcium, -1 for chlorine. Next thing we want to do, cross over, right? So on this side, we're just going to write it crossed over. So we know that means the 2 is going to go to the chlorine, the 1 is going to go to the calcium. So a lot of times people get confused because this 2 is already here. But remember, this is only Cl2 because it's by itself and it's part of Brinkelhoff. Once we combine it into a compound, that 2 goes away, right? It doesn't need it anymore because it's now in a compound, it's not by itself. This one, just coincidentally, the 1 from the chlorine goes to the calcium and the 2 from the calcium goes to the chlorine. So it is CaCl2 in this case, but it's not because this was a 2. It's because the calcium had a 2 charge and crossed it over. Okay? Last thing you'd want to do is balance. So we count on each side. Calcium 1, chlorine 2, chlorine 2. You don't have to add anything, or if you really felt the urge to, you could put a 1 in front of all of them to show that it's already balanced. Right. Next one, barium plus iodine. So we need to put this one in formula form first. So let's go ahead and do that. So barium, how do we write barium? We just put Ba, right? It's not part of Brinkelhoff, so just barium. Plus iodine we know is I. And what do we have to do to iodine? Hopefully you're saying it's part of Brinkelhoff. It has to be I2, right? So on the other side, we are going to just do exactly what it says, find the charges of each. So we know barium, if we look it up, is a +2. Iodine is a -1. So notice it's just like the one we just did, right? So when we write our product, barium gets the 1, and iodine gets the 2. So notice, just like before, it is already balanced, right? 1 and 1, 2 and 2, so 1, 1, and 1. And we're all set. That's it. Okay, this is just like making ionic compounds that like we did before Christmas. There's not really anything new in order for you to understand synthesis. Last one, we've got lithium plus phosphorus. So find the charges of each. Charge of lithium, +1. Charge of phosphorus, -3. On the other side, we're going to cross over. So put them together. Cross over your charges. So we know it's going to be Li. And the 3 from the phosphorus crosses to the lithium. So Li3. And the 1 from the lithium crosses to the phosphorus. So P. So you have Li plus P gives you Li3P. Check to make sure that it's balanced. In this case, it is not balanced at this moment, right? So what do we need to do in order to balance it? Count on each side. Notice 1 lithium, 3 lithiums. So that means we need to put a 3 there. And then 1 phosphorus, 1 phosphorus. So you can either leave them blank or fill in ones to show that they're already balanced. All right, not so bad. Okay, this one's really not super difficult. Oops, we're away. Next one, decomposition. Really not bad either. Okay, we're talking about decomposition. So let's go through our steps. I'll zoom out a little so you can see the whole thing, and then we'll do these examples over here. So first one, figure out which 2 elements you are forming. So remember, decomp is just going backwards. In this case, you're going to be given the formula, the compound already made, and you just need to break it down. Really, this is actually easier than synthesis. This is very, very easy stuff. All right, so figure out the 2 elements you're forming. Write each one blank its charge as your product. So we are going to write each one without. You don't want the charge on them because they're just atoms, right? They're not ions. They're just existing on their own without the charge as your products. Third step, remember to check for Brinkelhoff. If you have bromine, iodine, nitrogen, chlorine, hydrogen, oxygen, or fluorine, make sure you add a 2. And if you want to write that in there, you can add a 2 to any one of those and then balance it when you're done. Okay, just like we've been doing. You have to balance every reaction we do. All right, so first one, we're given KCl. We know that's potassium chloride. What is that going to break down into? Hopefully you are saying, Miss Vieira, that's going to break down into K, potassium, plus chlorine, right? K plus Cl. So we're going to write each one without its charge. We don't care what the charges are because they're atoms existing on their own. Remember Brinkelhoff. Does Brinkelhoff apply to either one of these? Hopefully you are saying yes, it applies to chlorine, right? So that means this has to become Cl2. And then balance. Okay, so we're going to balance, put our lines in. Notice 1 potassium, 1 potassium, 1 chlorine, 2 chlorine. So that means we need to add a 2 in front of the KCl to fix the chlorines. And now what do we have to do? Yes, hopefully you are saying also add a 2 in front of the potassium. Good. Next one. You're given Fe2O3. And you need to break that down. So, again, not super difficult. We've got, it's going to break down into iron. I'm just going to put the lines into balance already. And oxygen. We're not going to write charges, right? Write without your charges. Remember Brinkelhoff. Does Brinkelhoff apply to either one of these? Maybe. Yes. Possibly. Definitely. Right? O is part of Brinkelhoff, so we make it O2. And then balance. So we're going to check for balancing. Remember, do oxygen second. Don't do oxygen first because it'll wreck your life. 2 irons, 1 iron. So we're going to put a 2 there. And actually, this might be one of those where we have to go back and fix some things. We've got 3 and 2. So hopefully you guys have picked up now when you have 3 and 2, what do you have to make them both? They both have to become how many in order to make 3 and 2 equal? Hopefully you are saying they have to both be 6, which means we're going to put a 3 there. And what do we need to put in front of the iron 3 oxide, the Fe2O3? Good, we need to put a 2. So now 6 oxygen, but notice a little bit of a problem now, right? Once we added this, how many iron do we have over here? We have 4, right? And we had only put a 2 there originally, so we're going to cross that out and put a 4. Now everybody's balanced. 4 irons, 6 oxygen, 6 oxygen. And you're good. So the next one, you're given sodium sulfide, and we need to write out a balanced equation. So first thing you need to do is convert this to formula form. Alright, so sodium sulfide. I need the formula for sodium sulfide. So first off, ionic or covalent? Hopefully you're saying ionic, which means we need to look up charges and cross them over. Right, that's what you should be thinking in your head right now. Look up charges and cross them over. So we know that's Na and S going together, right? The charge of sodium plus 1, charge of sulfide minus 2. So this is going to become Na2S. Right, when we cross those. Now on the other side, we're going to write them separately. Na and S. Put the line in front of sodium sulfide too in case we need to balance. We're writing them without their charges over here. And then we need to think about Brinkelhoff. Does Brinkelhoff apply to either one of these? hopefully you are saying absolutely not, right? You don't need Brinkelhoff for this one. Neither one of those are part of Brinkelhoff. So now check for balancing. 2 sodiums, 1 sodium. We're going to put a 2 there. 1 sulfur, and we're good. So we can put a 1 and a 1 if you want to. Remember, you don't have to write the ones. If you're OCD and you need something on every line, then you can write ones. Okay? That's it for decomposition. Like I said, probably even easier than synthesis. Next one. Notice this is where the instructions start to get a little lengthier. These become a little more complicated. Single and double are definitely the 2 most complicated ones. Alright, so when you have to do those, they're going to take a little more time. So I'm going to zoom in so you can see the steps. If you guys could see me right now, my cat is currently sitting on my shoulders, cleaning herself. So it's super fun for me, really comfortable. Okay. So remember, in a single replacement reaction, we called that the home wrecker, right? The home wrecker reaction. Here she comes. And maybe you can see her. Yeah, that's her head. Hey, can you see? Look up at them. Hi. Can you see her? She's not being very sociable. There we go. Kitty, kitty. Look up over here. Over here. No. No, she's just, you know, walking around like we're not doing anything important. Okay, so again, remember we called this the home wrecker. So we know that right now K and Cl are together and iodine's alone, right? It's by itself. So what we know is the iodine is going to go in and kick somebody out, right? The job of predicting the product is figuring out who it's going to kick out, and then what your new compound will be and who will be left over on this side, over here. All right, so let's go through the steps to figure out how to do that. So figure out your single element. So obviously in this case it's iodine. Decide which element it will replace in the compound, and this right here, right, this is your key to success right here. Remember, positive replaces positive, negative replaces negative. Okay, so that's based on the charges that they are going to form. That's the only way for you to know who's going to replace who. All right, so if we look over here, all right, if we decide these elements' charges, well, we know potassium's a +1, chlorine's a -1, and iodine, when it forms a charge, will form a -1. All right, so if we remember our idea that positive replaces positive, negative replaces negative, then who is iodine going to replace? In this case, I hope you are saying chlorine. No, no, no. Dorothy, get down. No, down. Thank you. Iodine is going to replace chlorine. So you will have K and I paired up and chlorine on its own. Okay, this is the most important thing to remember here. Positive replaces positive, negative replaces negative. Okay? Now figure out the charges of your elements in the new compound and cross over. Next step, write the leftover single element again. Now it's just an atom, so we're going to write it without its charge. And then, as always, remember Bringelhoff and balance. All right, so we're going to go through, finish those steps on this first example, and then do it for the next 2. Okay. So far we've decided that iodine is going to replace chlorine. So as it says, figure out the charges of the elements in your new compound and cross over. So we know potassium and iodine are going together, right? Potassium and iodine are going together. And those are both just 1 and 1, okay? So on this side, when you cross 1 and 1, you're just going to get Ki. Notice that 2, nothing to do with this side, nothing at all, okay? That 2 does not travel with the iodine. It is only 2 because it's by itself. Attack of the kitty. like Godzilla in the world of chemistry. Can you move your wrinkly body? Thank you. All right, so K and I go together. Next step, write the leftover single element without its charge, so just chlorine. Remember, Brinkelhoff is chlorine in Brinkelhoff? Yes, so we're going to put a 2 and balance. That's it. Okay, so if we're going to balance this, we'll put our lines in front of everything. Let's go through and check everything. 1 potassium, 1 potassium. So far, so good. 1 chlorine, 2 chlorines. So where do I put a 2? Good. In front of the KCl. But now notice that kind of ruins our potassiums a little bit. We now put a 2 here. So now where do I need to put another 2? Good. In front of the Ki. And now just check your last one. 2 iodines and 2 iodines. That fixes everything. Put a 1 here if you want to. Everything's good. All right, next one. You've got barium sulfate, BaSO4 plus sodium. So, which one's your single element? Dorothy, hey. Sorry, she's scratching the carpet. Your single element, hopefully you said, is sodium. We need to decide which one sodium's going to replace over here. So to do that, just quickly look up charges, right? We know barium is a +2. Sulfate, SO4, right? That's your negative ion in this case. If not, don't break it up into sulfur and oxygen. Remember, we don't ever break polyatomic ions apart. So SO4 is your negative ion. What charge does SO4 have? So regular, you could look that up. Honors, you would need to think back to your sentence, right? We know for sulfate, the word is supper. The S, P, P, and R tell us that it's 4. The U and E tell us that it's -2. And then what charge will sodium form? Hopefully you are saying a +1. All right, so we can see if positive replaces positive, this sodium is going to kick out the barium. All right, barium's going to be by itself. The sodium and sulfate are the ones that are going to form a new bond. Okay, hence the idea of the Homewrecker reaction, right? Sodium's taking barium's place. Barium has to go live by itself. Okay, so next step, figure out the charges of the elements in your new compound and cross over. So we know our new compound is, I'm going to write it down here so we have room to balance, Na and SO4, right? We need to cross their charges. So sodium was a +1, so that 1's going to go to the sulfate. We don't write anything. The sulfate is a 2, so that makes this Na2. SO4, right? Next step, write the leftover single element without its charge. So we're going to write barium. Check for Brinkelhoff. Is barium part of Brinkelhoff? Absolutely not, so leave it alone. And balance. So if we're going to go through and balance this, so 1 barium, 1 barium, 1 sodium, 2 sodiums. So what do I need to do? Hopefully you are correct in saying you need to add a 2 in front of the sodium. So let's see, we did barium 1, barium 1, SO4 1, SO4 1, Na2, Na2. So we're good. So either leave them blank or fill in 1s on the rest of your lines. You are good to go. Last one, lithium phosphate plus calcium. All right, this one's going to take a little bit of work because it's in word form. Okay. Sorry, that's pretty crooked. Hold on. I'm going to try to fix that. Better? Maybe a little better? Okay. So first thing we need to do is put in formula form. Lithium phosphate. So we need the compound. We need the formula form. That's not a gross tale at all. we need the formula form of lithium phosphate. Okay, so we know lithium, it's just Li with a, oh, is this ionic or covalent? Hopefully you are saying it's ionic, right? So that means we need charges to cross over. So lithium is a +1. Phosphate, notice the 8, A-T-E, that means it's polyatomic. So that means you either need to look it up on your chart or have it memorized. So we know P-O, right? There's oxygens attached. The word that helps us remember phosphate from the sentence is which word? Hopefully you are saying phoenix, right? So P, H, N, and X tells us PO4. O, E, and I tells us -3, right? So we're going to cross those over. So we've got Li3, PO4, right? The 1 goes to the phosphate, so we don't write anything. The 3 goes to the lithium, so it's Li3. All right, plus calcium. So just write calcium and check for Brinkelhoff, right? It's not in an ion, or it's not in a compound, so we don't have to worry about its charge. So is calcium part of Brinkelhoff? Good. No, it's not, so just leave it like that. All right, now we are ready to decide on the other side to predict the products, which is what you're doing. Okay, so your single element is calcium. That's step 1. 2, decide which element it will replace. So is calcium going to replace lithium or phosphate? Hopefully this is becoming easier to predict. We know calcium, if it were to form a charge, is going to be a +2. Lithium, we had already decided up here, forms a +1. Phosphate forms a -3. So calcium is going to kick out lithium. Right now calcium and phosphate pair up. So that's what we're going to write on the other side. We're going to put together Ca and PO4, cross their charges because these are ionic. So the 2 from the calcium goes to the phosphate, so we need parentheses around it so it doesn't look like 42. And the 3 from the phosphate goes to the chlorine. So it's Ca3, PO42. I know it's a lot to write and remember, but that's what you would have to do, okay? Write, decide the charges, cross them over, follow all the rules we've been learning. Second, write the single element by itself without its charge and check for Brinkelhoff. Is Li part of Brinkelhoff? No, it is not, so we're going to leave it just the way it is. Last thing you need to do is balance your equation. So we're going to put our lines in front. Sorry, I didn't really leave a spot for a line in front of this first one. I apologize. Okay, so there's a lot going on here. So now you try to look forward into the future a little bit, okay? Obviously we can see we've got 3 lithiums and 1 lithium. So technically you would put a 3 here, okay? But notice your phosphates. How many PO4s do you have over here right now? You only have 1, and how many do you have here? You have 2, right? So that means you have no other choice but to put a 2 right here. Alright, so now you have 2 Li3PO4s. Now that changes your lithiums on this side, right? You no longer just have 3 lithiums. How many do you have now? You should be saying 6. You have 6 lithiums now, so that means what goes here? A 6. Very good. Alright, so that fixes your lithiums and your phosphates. Your Li and PO4 are now balanced. Now all we have left is calcium. How many here? 1. And how many here? 3, right? So what do I put here? A 3. Very good. Now that fixes everything. You can put a 1 there if you want to, or you can leave it blank. Alright, so your final equation is 2 Li3PO4 plus 3 Ca makes 1 Ca3PO42 plus 6 Li. That's a lot. Okay, that's a lot of steps that you just went through in order to write that. And notice, this is why your quizzes and tests are going to get shorter and shorter as we go through the rest of the year, because this is one problem, right? That took a long time just to do that one problem. I can't give you, even 15 of those on a quiz. That's not possible, right? This takes a very long time to do. So just know I understand this is a lot of work, but this is kind of where we're working to at this point, okay? All right, that takes care of single. Replacement. Notice in these boxes, I just didn't catch it. These say single and double displacement. That's okay. Replacement and displacement mean the same thing. So if you see displacement, it's nothing different. It's just a different word for the same idea. All right, so don't freak out. They mean the same thing. Okay, next one. This is our double replacement reaction. All right, double replacement. And remember, this one we knew of as our wife swap. So this is where they change who they are paired up with, right? Everyone's already in a compound. All they need to do is switch partners. For lack of a better way of saying that, that's exactly what they're doing. However you want to think about that in your head, as long as it's school appropriate, I don't care. Just remember, that's what double displacement or double replacement is. Switching who they're paired up with, okay? So, first thing you want to do, figure out where your compounds are going to split. All right, so in this first one we have NaI, that's not an L, it's an I. So sodium iodide and calcium chloride. All right, so to decide where they're going to split, obviously in this first one it's pretty easy. The sodium splits from the iodine, and the calcium and the chlorine split. Okay? Next, find the charge of each. So let's go ahead and do that. What charge will sodium form? +1 iodine, -1 calcium, +2, and chlorine, -1. All right, so 1, 1, 2, 1. Those are our charges. Next step, it says combine the two blank elements and the two blank elements to make your new products. This is kind of like the FOIL method that you learned in math. We're not mathing, don't worry, okay? But you can kind of think of it as FOIL. So we're going to do, well, kind of half of FOIL, not all of FOIL, just half of FOIL. We're going to combine the two outside elements and the two inside elements to make your new products and then balance. All right, so let me show you what I mean by that. So notice right now, sodium and chlorine are your two outside elements. So we're just going to put those together over here. Which one do we write first in our compound, the sodium or the chlorine? Remember, positive always comes first. So you're going to write the sodium first, and then notice it's 1 and 1, right? So you're just going to put them together. I'm going to do it down here so that there's room. So we're going to put together NaCl, 1 and 1, so just leave them like that. Plus, now you're going to put together your two inside elements. So calcium and iodine. Which one's going to be first? Calcium or iodine or calcium? Remember, positive goes first. Positive goes first. So calcium and then iodine cross their charges. Okay, the 2 goes to the iodine and the 1 goes to the calcium, so we leave it like that. So your two products are NaCl and CaI2. Hopefully you're with me. We'll do 2 more examples if not. So let's put our lines in front because we need to do some balancing, right? So, sodiums, how many here? 1, good, and here? 1. Iodine, how many here? 1. How many here? 2, right? So what do I put here? A 2, very good. Notice that 2 fixes our iodines, but now we have 2 sodiums. So what do I put here? Good, a 2. Now how many calciums here? 1. And how many here? 1. And chlorines, how many here? Good, 2. And how many here? 2. So we're perfectly balanced. Again, if you want to, put the 1 in the 1. We're good to go. Next one. AgNO3 plus BaSO4. So first step, figure out where they're going to split, and I'm actually going to highlight it this time so we don't have that line in between them. So we know in this case, sorry, wrong pen. The Ag splits from the NO3, right? We know NO3 is our polyatomic ion. Don't split it up. It has to stay NO3. So Ag and NO3 split, and then Ba splits from SO4. Okay? So those are your 4 ions: Ag, NO3, Ba, and SO4. Next step, find the charge of each. So, silver, couple of ways, right? Silver is a transition metal. So really, the easiest and most efficient way for you to do this is just to uncross, right? We know this NO3, that's nitrate. What charge does nitrate usually have, or does it always have? Well, nitrate, ATE, that means it's polyatomic, right? It comes from our chart. So regular, you could look it up and see that it's a -1. Honors, you can see that obviously it's NO3 because of the N, C, K, and Nic, and then it's -1 because of the I. So that means what charge did this silver have? It had a +1. The other way you could have done that was obviously look at your transition metal chart. Silver is one of those 3 exceptions. Remember, silver, cadmium, and zinc. Silver only can form a +1, but in the event that this wasn't silver and it was a different transition metal, you have to uncross. Okay, so +1, -1. What about over here? Barium, not a transition metal, so you can look its charge up. It's a +2, right? Sulfate, SO4, we know it's 8 from this sentence, so regular, you could look it up and see that it's a -2. Honors, you would know, well, SU, PPR, supper, right? The S, the P, and the P, the R tell you that it's 4. The U and the E tell you that it's -2. Alright, so you've got +1, -1, +2, -2. Next step, put together the outsides. Okay, so put together the Ag and the SO4. So Ag, I'm going to leave some space there. Ag, SO4, cross the charges. Okay, notice Ag was a +1, so that's going to cross here. So we don't have to write anything, right, because it's 1. The SO4 was a -2, so that's going to cross right here and make it Ag2 SO4. Next one, we're going to put together the insides, the NO3 and the Ba. Who goes first? Which one has to be written first in the compound? Remember, positive always comes first. It always has. We've never written the negative one first. Positive always comes first. So the Ba has to come first. And then the NO3. Cross your charges. So the 2 from the barium crosses to the NO3. So remember, if we're putting a number around a polyatomic ion, it needs parentheses. And then the 1 from the NO3 crosses to the barium, so we write it just like that. Okay, so you've got AgNO3 plus BaSO4. Notice all they did was switch who they were paired with. Now it's silver with SO4, so Ag2SO4 and BaNO3 2. Balance, and we're done. Okay, how many silvers here? 1, and how many here? 2, right? There's 2 silvers here, so what do I write here? Good. A 2. How many NO3s here? 1. And how many NO3s here? Remember, look at it all together. Don't break it apart. There's 2 of them, right? That 2 on the outside of the parentheses tells us there's 2 NO3s. So that 2 fixed that problem. Now, how many BA on this side? Good. 1. And how many on this side? 1. How many SO4s on this side? 1. And how many on this side? 1, right? So that 2 fixed our problem overall. So you can put the 1s in, don't put them in, I don't care. Just know that that 2 is what you would have to add in order to balance everything correctly. Okay, last one, and there's a particular reason I picked this, because you're going to see something funny that happens here. So let's go ahead and do this one. So where's our split in the first one? What's the first element, or the first ion? Where is it going to split apart? Hopefully you are saying the hydrogen splits from the NO3. And then what about over here? Where's our first ion? Where's our split? Good. The iron is going to split from the hydroxide, right? I know that's one of those ones on your chart. Neither class has to have that memorized. OH is hydroxide. Okay? Next step, find the charge of each one. So charge of hydrogen is a +1. Charge of nitrate, we just did that in this one, right? Which is why I always tell you to make a list of polyatomic ions on quizzes and tests. If you had done that, you wouldn't have to do this again. We already know nitrate is -1. Iron, okay, this is just like in the last one where I said you need to, if it's a transition metal, you have to uncross. So in this case, what was the charge of our iron? Well, we need to look up the charge of our OH to figure that out first, right? So if you look up OH, you know it's -1. So that 1 went here, which means what came from here? What came from the iron? The 3, right? The 3 crossed over. So that's iron 3. All right, so you've got H +1, NO3 -1, iron +3, OH -1. All right, so first 2 steps are done. Next, oh, sorry, I just realized those are numbered wrong. I don't know if they're numbered wrong on your paper, but they're numbered wrong on mine. I don't know if I caught that or not. That should be step 3. Balance should be step 4. Sorry if I did that on your paper too, or if I did that anywhere else. No, it looks like the rest are okay. Just that one. Sorry about that. Okay, combine the 2 outsides. So this is where I want you to notice something. So if we combine the 2 outsides, all right, I'm not going to write it yet because I want you to see something, because we're not going to write it actually the way that it looks at first. You're putting together H with a +1 and OH with a -1. I'm going to write that down here, but then I want you to see something. If we write H, OH, right? +1 and -1, so it's just that, H, OH. 2 hydrogens and 1 oxygen. How would we write that in like the real world? When you have 2 hydrogens and 1 oxygen, what is that also known as? Hopefully you're thinking, maybe you're saying it, the thing that comes out of the faucets in front of you when they're on. That's water, right? We don't write water HOH. We write it H2O. All right, so actually when you put these 2 together, water is one of your products. Okay, so that's the only time where you have to reorganize the way that you write that. All right, so H2O plus, now we're gonna put the 2 insides together. You have iron and nitrates. So Fe and NO3 go together, cross the charges. So the 3 from the iron goes to the nitrate. So instead of it looking like NO33, we put the parentheses around it. The NO3, 3. And then nitrate was a -1, which crosses to the iron, so we leave that the way it is. Now we balance. So put our lines in front. Hopefully, maybe you're picking up on the fact that when all of these are 1, except for one of them, that's probably going to be our only issue. But if not, we'll balance like we have been. So, in this case, I'm trying to think of the best way to explain this without actually being in front of you. Remember we put the water, the HOH together to make water. So you actually have to count the hydrogens from here and here, okay, to be able to balance this. So how many hydrogens do we have right here? You've got 1. How many do we have total over here? You have 3, right? Because you have 3 OHs. So 1 and 3 is 4. Here we only have 2. So what do I need to put here to make it 4? A 2. Good. We might have to adjust this a little bit. Yeah, we will. But it's okay. Let's keep going first. We're going to have to do some scratching out on this one. I didn't really realize that until now. How many NO3s right here? 1. And how many here? 3. Look, I broke my own rule, by the way. Nobody stopped me, because obviously I can hear you from where you are. I tried to balance hydrogen first, and what did I always tell you? Don't balance hydrogen first. Notice that's why it's wrecking my life right now. We're going to cross that 2 out. I'm sorry. Let's save that. So, NO3, 1, NO3, 3. So what do I need to put here? 3. Okay, look, I teach you well. I just don't follow my own rules sometimes. So we'll do the irons next. How many irons here? 1, and how many here? 1, right? Now we can do our hydrogens. So how many hydrogens here? That's 3. And how many here? 3, right? So total on this side is 6. So now we need to put a 3 there, right? To make it 6 hydrogens. And then check your oxygens. How many remember, we already did the NO3s. Don't count those oxygens. We just want to count these oxygens. So 3 oxygens here and 3 there. So we're good. That's a valuable lesson as to why you save hydrogen and oxygen for the end, because it fixed itself overall. But you don't want to try to do them first. Okay, last slide, or last part of your chart is combustion. This one's very simple. It's good kind of saving the easy for the end. Okay? The hardest part about combustion is recognizing it's a combustion reaction, which really isn't that difficult, so it's not asking you to do anything over the top. Remember, combustion is when you combine, and it says it right here, hydrocarbon and oxygen. So if you can remember to recognize a hydrocarbon and oxygen as your reactants, then your products are easy. They're always the same. What are the 2 products in a combustion reaction? We're going to write them right here. The first product is always CO2, or carbon dioxide. And what's the second one? Always. The second one is always H2O, or water. That's it for this one. As long as you recognize your hydrocarbon and oxygen, the product is CO2 and H2O every time. And then you balance at the end. Okay? So let's rewrite this in formula form. So tricarbon octahydride. Right? Tricarbon octahydride. A couple of things to notice. Carbon and hydrogen, so it's a hydrocarbon. Is this ionic or covalent? It is covalent, right? You should know that just because of the prefixes being there. So tricarbon, how many is that? 3, good. Octahydride, how many hydrogen? Good, 8. And then, whoops, I want to put an arrow. It's not an arrow, it's a plus sign. Plus oxygen. So plus O. What do you know about oxygen? That it is part of Brinkelhoff, so it's always O2, right? So C3H8 plus O2. Notice hydrocarbon plus oxygen. Just write your products. They are always the same. CO2 H2O. That's it. And then balance. Balancing is going to be the more difficult part of any of these. You've probably learned that from combustion reactions. They can be some of the most difficult ones to balance. All right, let's work on that. How many carbon here? 3, good. And how many here? 1. So what do I put here? Good, a 3. Now you do your hydrogens. How many here? 8. How many here? 2. So what do I put here? Good, a 4. Now check your oxygens. How many here? 2. We know it's always 2. That's always the one you have to fix, right? How many here total? 6. And how many here? 4, right? So 6 and 4 is 10. Hopefully that wasn't a challenge. What do I put here to make this 10 oxygen? 5. Good. So then this one just gets a 1 or nothing and you're set. Okay? Last one. C6H6 plus O2. Notice it's already in formula form, so this is even easier. Hydrocarbon plus oxygen. What are the products going to be? What do they have to be? CO2 and H2O. That's it. These are the easiest to predict. If only they could all be that easy. Let's put our lines in front because we know we got to balance. How many got carbon? 6. How many here? 1. So what do I put there? A 6. Hydrogen. How many here? 6. So here I'm going to put a 3. Maybe some of you who are looking into the future see a problem, right? If not, it's okay. We'll find it together. 2 oxygen. And then down here you've got how many total here? You've got 12 total here. And then 3 here. What does 12 and 3 make? 15, right? Is there anything we can put here to make this 15? Any whole number anyway? No, right? This is one of those times where if you end up with an odd number and an even number, what do? How do you fix this issue? You double what we've already decided, right? So we're going to say that's no longer a 6. If we double it, what does it become? Good, a 12. What is our 3 going to become? A 6. Good. What do I need to put here now? A 2 is what I'm hoping you all said. 2. I swear that's a 2. I promise that's a 2. Oh, that's not even trying. Let me zoom out a little. Okay, I have to rewrite that. That just looks like a half of a heart or something. Okay, 2. That's better. So now notice 12 carbon, 12 carbon, 12 hydrogen, 12 hydrogen. Now we need to fix this. So how many? We still have 2 oxygens there, right? How many total here? And I'm going to write this underneath because this is kind of a lot. 12 CO2. So 12 times 2. How many is that? You get 24 there. And then 6 water. So how many oxygen there? 6, right? So 24 and 6 gives you 30. Good. So now what do I put in front of O2 to make it 30? Hopefully you're mathing well. You put a 15 there, right? So now you've got 2 C6H6 plus 15 O2 gives 12 CO2 and 6 H2O. It's a lot of everything, right? But it's balanced. It's good to go. That's how you would do that problem. So notice combustion, not difficult. Balancing is the hardest part of combustion reactions. Okay. All right, that covers it for this. My guess is this probably went over 2 days, so well, it had to have because I'm already at 54 minutes. So work on the worksheet. This one's going to take a lot of practice. Okay, so focus on the chart, use the chart, study from the chart. You don't get the chart on the quiz or test, so please make sure you do the practice. Don't just copy it. If you just copy this practice, it's going to blow up in your face on the test. Okay? That's all I have for you. Miss you guys. Good luck on the worksheet. Ask if you have any questions. Google. Ask Mr. Fier. Ask Mr. Perkins if he can help. Miss you and have a fantastic day.